Welcome you once again, friends. So, in the last lecture, we learned about vector algebra, and from the today's lecture, we start differential calculus. And today's topic is in the differential calculus dy by dx or derivative as a rate measurement. So, let's start. Now, consider two quantity y and x interrelated in such a way that for each value of x, there is one and only one value of y. So let's see what is it. So exactly, let's consider two quantities y and x, and we can plot these quantities like this. And the y and x are interrelated to each other, that there is only one and only one value of x for the particular value of y. Like if you saw this graph, there is only one value. You can find there is only one value for any value of y for the any value of x. There is only one value of x for any value of y. Okay? So simply this is the relation between x and y. So you can understand now. Now let x be changed by small amount delta x. Let's suppose let's consider 2 points A and B, and between A and B the x be changed by the small amount delta x. If we go from A to B, the x is changed by small amount, which is delta x. Distance to the A is x, and distance to the A in the y-axis is y, and also y change delta y. So corresponding change in y be delta y. Now so that the rate of change seems to be equal. So as we know, if we take a plot, or if the rate of change in delta x in delta y with respect to delta x is delta y by delta x. So this is the simple method to calculate the plot. Let's see it in another word. For simplification, if A is the point x and y, so here as we know that distance to the A in x-axis it is x and in y-axis it is y. So A is the point xy, and B is the point x plus delta x. So if you measure the distance to the B, so this is x plus this is delta x. So distance to the B on the x-axis is x plus delta x, and distance to the B in the y-axis is y plus delta y. Now then, as we know, then this AC is delta x and this BC is delta y. So if we draw a triangle and we find the slope, so the rate delta y by delta x is equal to the slope of the line AB. If we consider this AB as a line, so this delta y by delta x is the slope difference between 2 points. So simple equation of the slope is delta y by delta x is equal to BC by AC is equal to tan theta. But this is the equation of slope for the line AB. But as we see, this is not a line, this is a curve. So let's see how it find. So this is our simple graph. But slope is not same at everywhere in the plot, because this plot is not a line, it's a curve. As I say, this slope is not a line. This slope is, or this our plot is a curve. Then we want to define rate of change for each and every point of curve. So rate of change at each and every point is different. Like if I take this particular point, you can see the laser cursor. So at this particular point, the x is changed. The y is changed with respect to x slowly. But at this point, where slope is hardly upward, so at this point, as the upper point, y is changed with the minor change in x increase y too much. So I hope you can understand that a minor change in x at this point, the minor change in x, if I change x from here to here, then y increase here to here. So this minor change in x increase the y too many or too much. So this is something that this curve is not same at everywhere, and because of this, uh, plot or slope of this curve is not also same at every point. Okay, so for this we can define something new. Now take delta x and delta y is very small as they tend to 0, then distance between point A and B is also tends to 0, and they looks like they both are 1 point or they both are merged to each other. So yeah, this if you see in this figure, these 2 points are come closer and closer together, and at a particular time or at a particular point they both are merged to each other, and distance between them delta x is tends to 0. Now they both point are look like they are not separate, they are only 1 point, but there is a small distance which is nearly equal to 0, and that's why, because we can't say that delta x is equal to 0, we say that delta x tends to 0. So with the use of limit, the slope is now defined as limit delta x is equal to 0. Here we want to use limit, and our limit is delta x tends to 0, and we apply this limit on our equation delta y by delta x. And in this equation is we can define as dy by dx, and this is something very well known equation, which is equation of derivative of y with respect to x. So in the 11-12 we studied derivatives very well, so we know about derivatives, everything. Okay, but here we use derivative this dy by dx as the rate measurement. So for this type of slope which is which is not same, behave not same at everywhere, so for this type of slope or this type of plot, we want to use for the measurement of rate of change, we want to use the equation of derivative, and that why the reason the differential calculus is start with the defined derivative, defined dy by dx. And something important about this differential calculus or the rate measurement property is that if the function y increase with an increase in x at a point, so dy by dx is positive. So let's see how. So this is, as you see this graph, in this graph, the as I increase the x, the y is increase. So y is in the increasing order. So as I say, the function y increase with an increasing x at a point. So at any point, if I increase x, y is also increase. And for this type of phenomena, dy by dx or derivative of y with respect to x is also positive. The rate of change is also positive. So here I use word for this derivative is rate of change of this plot is positive, because both delta y and delta x are positive. If I take a 2 points and take a difference in y axis and difference in x axis, delta x is also positive, delta y is positive. So in simple word, we can say that delta x greater than 0, delta y greater than 0, then dy by dx also greater than 0. If the function y decrease with an increase in x at a point, so delta y is negative and delta x is positive, and hence dy by dx is negative. So here our y is not increasing with increasing in x. Here the y is decreasing with increasing s. For this type of slope, the difference delta y, difference between two particular point on the y-axis is delta y, and on x-axis it is delta x. So here, because of y is decreasing, the delta y is negative, and as usual delta x is positive, and because of this our derivative or the rate of change is negative, because this graph is go downward. So rate of change is decrease because y is decrease with respect to x. So rate of change is decrease, and then dy by dx is negative. So if we use simple words or simple equation that delta x greater than 0 and delta y is less than 0, then dy by dx is less than 0. So in the simple one, if delta y is greater than 0, so dy by dx is greater than 0, and if delta y is less than 0, so dy by dx is less than 0. Okay, so this is something simple and important thing about the rate measurement in the differential calculus. Further about differential calculus is we learn in the next lecture. Okay, I hope you all enjoy the lectures. Thank you very much. તો મળીએ હવે સીધા નેક્સ્ટ લેક્ચરમાં. ત્યાં સુધી જય હિન્દ, વંદે માતરમ.